Question number 6. What is the freezing point of the solution containing 8.1 gram bromine in 100 gram of water, assuming that the acid would be 90% ionized? Given that Kf for water is 1.8 Kelvin per mole, options given are A, 0.85 degrees Celsius, B, minus 3.53 degrees Celsius, C, 0 degrees Celsius, and D, 0.35 degrees Celsius, that is minus 0.35 degrees Celsius. Well, in this entire scenario, let's take this one. The first point that we know is the concentration of solute is 8.1 gram, right? So therefore, the concentration of solute is equal to 8.1 gram, right? Now, concentration of solvent is 100 grams. Alpha in form of percentage is 90%, while alpha value, we can take it for 0.9, right? That is the degree of dissociation, and the alpha value will be as 0.9. Now, what we know is about the delta TF, as it is given as a freezing point. So this is equal to Kf into M into I, right? So therefore, what we have is the I is equal to, Van 't Hoff's factor is equal to delta TF over Kf into M, right? So therefore, this one is nothing more than for bromine in water, it will react in order to form HBr, right? So therefore, it can split as H plus plus Br minus. So the total number is going to be 2 ions which are going to be formed. Now, this is very important so that we can proceed further. I is also equal to, as we know, as 1 plus of N minus 1 into alpha. So therefore, I is equal to 1 plus. Now, N number is 2. So 2 minus of 1 is 1. So therefore, 1 alpha. So therefore, alpha value, we already know that is 0.9. So I value is 1.9, right? So this is one of the important equations that we would like to take into consideration, and let's proceed further. So therefore, as I value is 1.9, we will use it further. So delta TF is equal to 1.9, right? So 1.9 value into Kf for water is given as 1.8 into, now 8.1, now M modality. Now let's open the modality. So therefore it is going to be as 8.1 divided by 80 into 1000 divided by 100 grams, right? So when we solve this, we get the value of delta TF as 3.53 degrees Celsius. But delta TF is equal to the freezing point of water minus freezing point of solution, right? So therefore, what we have is freezing point of water is 0 minus 3.53 degrees Celsius. So therefore, what we have delta TF is equal to, so 0 minus of 3.53, it gives us minus 3.53 degrees Celsius as the answer. So it is nothing more than the option is B. Thank you.